Hello class, still on circuit theorems. This time we'll proceed to maximum power transfer. In many practical situations, a circuit is designed to provide power to a load. There are applications in areas such as communications, where it is desirable to maximize the power delivered to a load. Let's say we have a Thevenin equivalent circuit connected to a variable load. The power delivered to the load is this one, I squared RL, which ang I na to is VTH over the total resistance. So we have eventually this form. For a given circuit, si VTH or RTH, they are fixed. And considering this formula, para sa toong power, kung fixed si VTH or RTH ang pasabot, si RL ang pwede na to ma-vary in order to have this maximum power transfer. Now, if you will graph this, P versus RL, you based on nga graph, makita nato that there is just a certain value of your resistor or of your load resistance such that makahatag kining circuit nato og maximum power ngadto sa ato ang load. Kung wala kung dili equal ana nga particular nga value sa ato ang load, dili maximum ang power niya mahatag, di ba? So unsa ni nga particular value sa to ang load resistance nga maximum ang power mahatag sa to ang circuit. Well, as shown in this graph, RL should be equal to RTH. Kumbaga, at this value sa imong load resistance, maximum ang mahatag nga power ni circuit. Now, yun sa man pag-derive tuod. Kadamdam pa mo sa inyong calculus 1 sa inyong derivative. Diba? To get the maximum of a function, ang himuon kay, we set the derivative of that function equal to 0. So, kung ano to sa ang derivative, sa to ang function, sa to ang p, and p, diba, is equal to this form, this expression. Kini kay constant naman si VTH, diba, kay sa circuit, constant naman si VTH or RTH. So, constant si VTH, so diri na natin sa gawa. So, diri na natin mag-operate. Karamdam mo sa inyong fraction, basta mag-derivative, it's low derivative sa high minus high derivative sa low over low squared. So that would be low, that's RTH plus RL squared. Derivative sa high, that is RL, derivative ana with respect to RL, so that would be 1. Minus high, that's RL, derivative sa low, derivative ani kay 2 RTH plus RL times ang derivative sa sulod. RTH is constant, that's why derivative ana kay 0, RL derivative with respect to RL, that's 1. Then low squared, that is RTH plus RL to the 4th power. And as you can observe, common si RTH plus RL, aning duha ka terms nato. So we can factor that out. So that's why we have RTH plus RL, and multiply nato sa nabilin nga RTH plus RL minus 2RL. Then ma-minusan ni, mahimo ng 3, di ba? So RTH ang nabilin, RTH plus RL minus 2RL, napada ay V squared, VTH squared over RTH plus RL cube na. Okay, na-minusan naman siya. So kay na naman ta expression karon sa ato ang derivative sa ato ang power with respect to RL, then we have to equate that to 0 aron makuha ang iyang maximum. So ato expression sa ato ang power with respect to derivative sa atong power with respect to RL is this one. We set that equal to 0. Then aron nga ma-eliminate na to ni. So we just have to multiply with this factor, RTH plus RL cube over VTH squared. So, nalang tayo nabilin ng RTH plus RL minus 2RL. Sa ito pa natin RTH minus RL. Balhin, pasabot, RL is equal to RTH. This means that the maximum power is transferred to the load when it is equal to the Thevenin, when the load is equal to the Thevenin resistance. Ito pa, ang condition for maximum power, ang resistance at ang load is equal to ang Thevenin resistance. And kung nga naman gani, then ang maximum power, di ba? Sa ganina, it's I squared RL. Si I nato is equal to VTH over ang whole nga resistance. Then kung si RL ka equal to RTH na pasabot, nanay 2 RTH, di ba? Then squared times ang RL nato is equal to RTH. That would be VTH squared over 4 RTH. Okay? Let's have an example. Find the maximum power delivered to the load. So, ang taon ganito, dapat i-reduce, i-convert na nato to its Thevenin equivalent circuit. So, para sa Thevenin, RTH o VTH itong pangitaon. Para sa pagpangita kay RTH, we turn off all the independent sources. So, kini ma-short, kini ma-open. That's why as seen sa terminals AB, RTH is just parallel nimo pag man i-add nimo sila kana ka-series naman dayon. So, 2 plus 3 plus 6 parallel 12. So, that would be 9 ohms. Tanata ni RTH, so karon VTH siya punta. Now, by inspection, si I2 is equal to negative 2 amperes. Di ba? Then, dari na dito kay mesh 1. Mesh 1, it's negative 12 plus 6 plus 12 sa to pa 18 I1 minus 12 I2. Okay? Substitute si I2, so we have I1 equal to negative 2 over 3. Tapos KVL at the outer loop, so we have negative 12 plus 6 I1 plus 3 I2 plus 2, unsa man iyang current dere? Diba? 0 man ni, no? I-open circuit man na. Sa to pa, walay current kani agi dere. So, plus ang imuhang voltage, VTH. Okay, so substitute lang ang mga values. So we have VTH equal to 22 volts. Hence, our maximum power is V squared TH over 4 RTH. That would be 22 squared over 4 times 9. So we have 13.44 watts. Napasabot, ang kini siya nga circuit, ang maximum power nga mahatag niya ani nga load is 13.44 watts. Okay? And that's it. Thank you for listening.